Excellent. Hi, guys. Thanks for coming. I'm going to be talking to you guys today about geocoding the world in Perl, which is, of course, the best language for doing anything. I work for a company called Nestoria. We're a property search engine based in 9 countries. This is me. I'm CTO at Nestoria. I like speaking at YAPC events and other Perl events, especially in London. And I chose this photo because of this T-shirt, which has a regular expression on it. So if you can figure it out, or if you can't, come ask me. This is Nestoria. This is our property search engine. Here I'm looking at Spain or Mexico or something. And euros, Spain. And this is what most people think of when they look at Nestoria, kind of the public face, the user-facing part of the system. But that's about 40% of what we do, and the remaining 60% is all back-end data quality, deduplication, natural language processing, and of course, geocoding. And you can see here that the product is very geo-focused, very map-focused. We've got the map on the side. We've got listings on the map. You search by location, so it's not free text search like you might find with other search engines. You only search by location, and then you filter down from that. And every listing has a title that's also address-based. That's what people care about when they're searching for property, is number one, location, location, location. Where is the property? So a quick introduction, very quick, as to what geocoding is. It's becoming more and more familiar, common for people to understand geocoding, especially as mobile devices, everybody's walking around with a GPS these days. Geolocation is becoming very critical. And this is what we consider geocoding. You take text data, any old input, and you try and turn it into a pair of coordinates, latitude and longitude, or whatever other type of coordinates you like that describes a point in space, or a bounding box, or a polygon shape. And the geocoder is the bit in the middle that knows that this address is here. Sort of fuzzy information, discrete information. And a quick intro to geocoding at Nestoria specifically. So I've already mentioned we're a property search engine. We're focused on property listings. And so we get property listings in, we geocode them, and we have our results output. So, big surprise, our geocoder is a geocoder. The property listings come in as XML from our partners, various property portals around the world. And then we geocode, which is mostly done in Perl internally. And then we shove the results into a database. And that's how the website works. It's a little bit more involved than that, but that's the part that's interesting for this talk. So about the input data that we have. So we work in 9 countries. They have their own challenges. This is an example listing input for a location part of a listing that we might get in the UK. You can see we get full address, postcode, latitude, longitude, coordinate system, coordinate confidence. So as well as getting the latitude and longitude in the input, we're also getting some metadata about how accurate that information might be. And then we've got discrete information down here, which we call place names, street number, street, and town. So a ton of information here. And actually, it's very easy to geocode in the UK, even with a lot less information than this, because the postcodes in the UK really describe where the place is. So this is just the postcode part being geocoded. LN76UU is basically that point, and that's Walled View, which is where this property is. So geocoding in the UK, especially now that the postcode data is freely available. It's now free. It was pretty cheap even before that. Is very, very easy. Germany, still quite good. In most countries in Europe, the postcode information is not as detailed as the UK. UK, you get a street or even a segment of a long street. In this case, in German, PLZ, postcode Leitzeitung, so no, not Zeitung, Zahlung, so yeah, I got it, is actually bigger than the town, the Ort, actually, Balhatchet. So the postcode is actually describing a region that's bigger than a town, quite different from
usually the community.
Yeah, yeah.
Cities are part of it.
Yeah, in big cities, it can be smaller than the city, but it's much bigger than a street like it is in the UK. But this is great information. We've got the street name, street number, the town, the state, the postcode. We can do something with this data. France, surprisingly, bad data. And this isn't any dig at France specifically. This is specifically the property market in France and the estate agents in France. The market in France is such that the agents can actually, so a property can be advertised with multiple agents, and so the agents basically jealously guard the data, and they try and be very, very vague about it. More on this in a bit, and sort of how we've...
They actually lie about it.
They'll lie about it, they'll be very vague, they'll completely leave out important information like the town that the property is in.
This seems to be like recruitment consultants and jobs.
Yes, the property market, cars, jobs, all vertical search, the aggregation, they share similar problems. That's definitely true. And then India, nightmare mode unlocked. Now this has got a lot of information, right? You've got the latitude and longitude. You've got the full address, building. So the full address: Highland Landmark, Jangama, Kote, Vijayapura, Devan, Hali, Bangalore, Karnataka, India. Lots of information. Here's those places on a map. They're kind of roughly clustered in the same area. India's a really big country, so this is a pretty large area. The state actually, I think that's just that. Yeah, that's Bangalore, the really big bounding box that goes off the bottom there. These are kind of smaller places, and basically the address information in India is of the form: this place is kind of near this place. It's behind there. It's opposite this. It's in that region.
I had a colleague where his address was get to this post office, turn
Yes.
left, and we're about 3 houses down.
Yes, that is a valid address in India. It's, if you didn't hear, get to this post office and turn left and we're about 3 houses down is the sort of address information that you deal with in India. And we have to try and deal with this programmatically. So we internally built our own geocoder. And this was partially because the data is so difficult. It's partially because the property data is, so in the case of France, is very specific to the property market, and we can put in optimizations just for ourselves. And it's partially because the publicly available geocoders provided by a lot of companies that have map APIs, Google, Bing, Yahoo, OpenStreetMap, whoever, have APIs, but they have very low limits, and we have to do this at quite a big scale in terms of the number of listings that we're geocoding and re-geocoding if we think we've made an improvement or when we get new listings in. So I'm going to quickly describe how we've approached this in Perl. First thing that we really needed is the data, the location information about this. And we looked at a lot of the solutions, and for a while we were actually buying data from big data resellers, the kind of people who make your satellite navigation systems. But we've more recently moved to a more open model using Yahoo GeoPlanet and OpenStreetMap as our 2 biggest data sets, which are both completely open. And then in various countries, we have other open data sets. So INEGI is in Mexico, data.gov.uk is UK, of course. And then we have our own amendments, which we've tweaked over the last few years of working in these countries. And then once we've got the data, we've got our geocoder. So the input is the geodata and the listing data that you want to prioritize. I'm going to run through this quite quickly. So you probably can't read this, but I'll read it for you. You have the address, street, town, postcode that was listed in the XML there. At the bottom here, we've actually got the full description of the listing as one of the inputs to the geocoder. This is quite different from how a lot of geocoder APIs work, in that most geocoder APIs will want you to give them something that looks roughly like an address. Our geocoder just takes any old text and tries to find what location that text is referring to. And this comes back to the point I made on France. So in France, the agents jealously guard the data. They don't want to give the portals, the other agents, the structured data. But they want people to know where the property is. They want the people who are going to go through the agent to find the property they're looking for. That's still their eventual aim. That's how they make money. And so the way they get around that is to put the address information into the full description. And they'll put it at the end, they'll put it at the middle, they'll kind of say it's 2 kilometers from here or whatever. And there's often little tidbits of geographic location information in that full description. And so we built our system to take that in as one of its inputs. So we put that all into one big string, and then we split that up into words, and then we tokenize those words, which basically just means we add some metadata, we lowercase them, we normalize them in some ways. Some of the metadata on the normalized tokens is the original word. So you can do things like match case insensitively, but score better if it's a case-sensitive match. And then we turn those tokens into what we call terms. And this is kind of another interesting point on geocoding where you're getting strangely formatted input. So we turn those terms into A, B, C, A, B, B, C, A, B, C, B, A, C, B, and then the really weird one at the bottom, C, A, B. So you have 3 words in the input. Let's say, as an example, Eiffel Tower, comma, the, or Eiffel Tower, comma, la. And then the geodata listed as the Eiffel Tower. And so we need to put in term CAB as one of our inputs. And we actually get a lot of this, especially in sort of Spanish, French, Portuguese, that sort of language. So this term CAB actually really helped us with our geocoding results. Those GeoIDs are then looked up against the data. So those terms are then looked up against the data, which is going to find places, which we call GeoIDs. So some of the terms are going to match places. Some of the terms are going to match more than one place. Some places are going to be matched by more than one term. But you end up with a list of places. And then what we're trying to do to find the one place is to build a hierarchy of those places that we've now found. So by hierarchy, I mean geographic hierarchy, this place is inside this place. So in this case, we've actually developed, we found 5 GeoIDs, and we've built up 2 hierarchies of 2 or more GeoIDs. So we've got 1 and 2, and 4 and 5 are hierarchies. 3 is all by itself outside of that hierarchy. This we originally did in pure Perl, and it was fine, but it didn't scale very well to really long inputs. We've now got a solution that's using libgd to actually draw the GeoIDs, the bounding boxes, onto a canvas using image software. And that has the great advantage that it's basically written in C, it's really, really fast, and it's really optimized for finding, is this on top of this thing, because you can use colors to do that. And it has the added bonus that it makes debugging really easy, because as a side effect, you get images, which you can then use to figure out how it looks. So then that turns into the hierarchy. So GeoID 2 is inside GeoID 1, GeoID 4 is inside GeoID 5. We do a lot of work to then score those hierarchies on a number of different weighted scoring things, like did the information come from the full description, or did it come from the discrete information? Was it an exact match or just a case-insensitive match? That sort of thing. And then eventually there's a winning hierarchy. And then for our output latitude and longitude, we take the center point of the smallest place within that hierarchy. And it does all that in about 100 milliseconds, thanks to Perl and libgd and a little bit of NYT-prof. So as an aside, we also rely on some external geocoders. I mentioned that some of them have very low usage limits. There's lots of them available, though. If you look on Perl on CPAN for geocoder, you'll actually find lots and lots of modules designed for talking to remote geocoder, public geocoder APIs. And we've actually written, a few years ago now, geocoder many to help you multiplex between those and keep within the usage limits in that case. And so our geocoder takes the external ones where it thinks it should contact the external one, takes our internal geocoder and picks a winner between those options. Now, of course, there's some bad news. You might all be thinking, maybe this is the talk where Nestoria announces they're going to open source all of this wonderful code, and that's not what I'm here to tell you. I'm sorry, we're not going to open source the entire thing. There are bits of it that we're going to be opening up and putting on the CPAN, putting on various places. But I do have good news, which is that we are opening up through an API. So you can go to geocoder.opencagedata.com. OpenCage Data is a sister company to Nestoria. And Geocoder OpenCage is the CPAN module, which of course already exists and is on CPAN. The API is currently completely free, and we've committed to always having a free tier. It's very, very new. Please try it out and give us your feedback. There's a Twitter and contact form to give feedback. I will mention, so I mentioned at the very top of the talk that Nestoria is in 9 countries. The OpenCage Geocoder uses Nestoria's geocoder for those 9 countries. And then for the remaining 400 countries, it uses a variety of other tools, OpenStreetMap's Nominatim, the Data Science Toolkit, and the Two Fishes Toolkit. It doesn't use any of the remote APIs that I mentioned to try and answer your questions. So it will work in countries like Bulgaria, Russia, Japan, wherever. But in the 9 countries where Nestoria is in, that's where you're getting that great technique that I described to you. Thanks very much for listening. And does anybody have any questions?
What's the input to the open source model? Is it like XML, structured XML?
Oh, right. So the input to...
Can you repeat the question?
Sorry, yeah, I will. Yeah. The question was, what is the input to Geocoder OpenCage or the OpenCage Data Geocoder API? The answer is that it takes a text string and also takes a country for you to give it a hint on both what country you want, what country you expect, because normally you know what country, but also the country will affect what language you get results back in from certain geocoders that it's using behind the scenes.
I'm wondering, are you giving any feedback when you find out that... Thanks. If you find out that certain data set, for example, the Yahoo service gives you a number of results and OpenStreetMap does not, are you giving these guys a note that, listen, there are some queries that give back a number of results in Yahoo and in your search that do not?
So was your question, if you're using the OpenCage geocoder, do you know which source was used for each result that you get back? Or are you talking about feeding back feedback to other companies?
Yeah,
the
second one.
Okay. So the question was about when we find geocoders either to be good or bad, do we feed back to the companies? In the case of the open source geocoders that we're using behind OpenCage Data Geocoder, we're using Nominatim, which is from OpenStreetMap, Data Science Toolkit, and Two Fishes. We have been giving them feedback on what we find them to be good at and what we find them to be bad at. They're mostly based in the UK or the US, I think. And in the case of remote geocoders, Yahoo, Google, Bing, etc., we haven't been feeding back. They don't, as far as I can tell, give a good method for feeding that sort of information back. And also, we're more and more trying to rely less on those services.
And what about OpenStreetMap?
So OpenStreetMap is a data set. For those of you that don't know, it's basically the Wikipedia of maps. So it's an open data set, and people contribute places, roads, streets, locations to it, landmarks as well. And in the case of OpenStreetMap, they have a geocoder-ish place name lookup called Nominatim, and we've been feeding back information to both of those.
Excellent question.
Just one last question. In one of your previous slides that you use a confidence score. How do you compute a confidence score?
That's a good question, and it's something that isn't done very well. I think we could do a lot more effort to make the confidence score more successful. So in the case of the confidence score that we do here, it's the size of the bounding box of the place that we return. So, for example, that usually means if you match a street, then it's more successful. A small area, it's more successful than if you just match against a town. We basically have a score from 1 to 10 or 0 to 10 based on how big the place is. In the example I think you might be referring to, if I can go all the way back to this way. So this is actually some data that we got from one of our partners. And this is telling us that they've computed already a latitude and longitude. But they've computed that with Google Maps. That's what the unit Gmaps means. And Google Maps gave back this confidence score of 5. So in this case, we'll take the latitude and longitude that they've given us, and we'll try and compute a better result. But we'll use it as one of the hints to our geocoder to let it decide whether it's found the right place or the wrong place. All right, thanks very much.